Hey guys, welcome to the second part of repairing 11 or attempting to repair 11 power banks and let's see the results that we got for the capacity right here. Alright, so you remember this small power bank? This one I said it's number 10. I said I got it from UK a few years back. I got the capacity back and it's 2166 milliamp hours. So the original capacity was 3000 milliamps and now it's only 2166. To be honest, I don't think it's worth keeping this around because the capacity is so low. I specified that to call a device repaired, it should have more than 90% of the life. So this one will be on the side. Let's get to number 9. Number 9 is this one. It's also LiPo, and you can see that it's 9479 milliamps from a total of 10,000 milliamps. This is I think we have a label right here, but it's covered, but it should say 10,000 because on the case it was 10,000 milliamp. This one, for the battery at least, it's been recovered. And the capacity, it's alright, it's fully charged, or at least it was fully charged. Now we have the opportunity to test the voltage. Let me switch the camera real quick. We can test the voltage right here, like this, and see if it had any self-discharge after the test was completed. So it sits at 4.07 volts and it was charged to 4.2. There's a bit of self-discharge, but not that much. It's still around 0.1. It's still around 4.1 volts, so I will attempt to put this one back and see if it works. Let's get another LiPo cell. This one has two cells in parallel, and if you can see this one, the capacity is 9843 milliamps. Let's check the voltage as well. Alright, so voltage is 4.11 volts. That's okay. This is a good voltage for lithium ion cells. The next one is puck number 7. Puck number 7 has this capacity right here. So it's 19,209 milliamps. This is definitely matching the required capacity to call it recovered. Let's see the voltage as well. It's 4.18 volts. That's okay. It's very good. And we have number 8 right here. So it's 19,327 milliamps. Let's check the voltage on this one as well. .17. Number 11. Check it out. 19,038 milliamps. From a total of 20,000 milliamps. That's good enough for 18. So these red cells, these are pretty good. we have number 6 right here. 19,562 milliamps. 4.17. Right. So next one, it's, I think it's number 2. Check it out. So it's 9,331 milliamps. This is good. Next one, it's 9,324 milliamps. This one, it's 8,734. The cells are 2,000 milliamps each, so I will consider this from repairing the pack. The last one, it's 9,327 milliamps. So out of 11 we should have 9 working packs. Alright, so the battery packs have been restored. They have working voltage and they are ready to be installed back into their housings for 18. Let's see if these ones self-discharged for 17. This will probably work as well. This pack. Both packs will probably work if you want to use them, but well, I said the rules already on what we can consider a working pack and not. One, 2, 4, 6, and with 3 we have 9 packs. Okay, now to get the corresponding cases, we need 4 of these cases. So the big ones, they were all recovered. In this case, this is number 6. It has the screws inside. And I think this one is with the blue cells. So we have everything here. Let's start with number 6. In order to determine if this board is working fine, I will be powering this board by soldering back the wires. At first I thought that I will be testing this with my bench power supply, but now if I have the voltage set on the battery, I will just test it with the voltage from the battery. I just noticed that during this assembly I punctured this battery right here. Right. So this is no longer safe to be used, unfortunately. It smells like lithium ion, and I will not be assembling this back. So this was my fault, but still this is an unworking power bank, so I'll put it aside. Right, now we can we have 8 devices left. Let's see from 8 devices how many we can actually fix with everything it needs. Let's get this off. I remember we had one with broken temperature sensors that we had to repair, but this one looks fine. So which case is this? Number 2. Alright, so the wires were soldered back. Let's see if this will power on. Let's try charging it. Alright, so at first it did not wanted to show any power, but now that I plug the charging port on, it shows like it's charging, and now it shows the level of the battery. Alright, that's a good sign. You can see that it actually charges the battery. And I will let this charge. If you remember, another factor to determine if this is a fixed power bank, it should show that it's fully charged. So now we have to let it charge and check it afterwards. But I want to assemble it back and let it charge in its original case. I'm using some Kapton tape to isolate the positive and the negative leads. Okay, so this is number 2. Alright, so this device needs to be fully charged and show me that it has 4 bars on battery to call it fully restored. Alright, so this is the one which has a broken temperature sensor, or it's a broken lid of the temperature sensor. I will try to solder that back. It has some silicone on top, which made it impossible to solder on the pad. Now it looks like it's going to stick. Alright, so the temperature lid was soldered back. Let's see if we can restore the functionality. This is number 3 and this is it. Doesn't really matter that much, but I am trying to keep them as I got them out. Same thing, it will not open if we don't plug in the power. Alright, let's assemble this sucker up. Alright, so I finished with assembling 3 small power banks, the small ones, and I want to test if they also get the power out. Okay, so I'm using this USB-C. You can see that it started charging. Alright, so this one is charging. Alright, so 3 of them charge fine. We'll see if they get up to 4 bars on the displayed battery capacity right here, and we'll call them done. Let's move to the next ones. Alright, let's start with the big one. I remember these were a little more difficult to assemble back, because we have to drive the nickel strip back into the PCB. Let's see what we can do. I will also check that we have the temperature sensor solder, and it's not. I'll have to fix that first. Alright, so to make my life a bit easier, I'm going to use this sucking pump. We'll add a bit more solder here. to melt it properly. And then this sucking pump will help cleaning up the extra solder. Let me see if I can focus so you can see. So I will try to get this as clean as possible. Alright, so I soldered the board in place now. I will fix the temperature sensor with a bit of Kapton tape. And now I can put the other section in. Alright, so it appears to be charging as well. And you can see that this one shows 4 bars, and this is what we're looking for. We're looking to see 4 bars, 4 full bars. Let's see if the light works as well. And we have light. Good, let's see if we get the ports working. If it can charge my phone. And this one seems to have fast charging capability. It says 1 hour and 6 minutes left until full. Let's test the other port. Both ports work fine. That's great, guys. We have one device that's confirmed to be fully working. It charges, it discharges on both ports. We have full capacity, and we also have the light working. Let me put this back into a case now. And don't forget, guys, this is the video where we're seeing who won the $100. Who was right in guessing the right amount of power banks that I'm going to fix. Let's see, we have one for now. We have one for now, and other 3 that must be confirmed to see if they will fully charge. We'll have to let them fully charge overnight and then check it out in the morning. Alright, so this one is confirmed. 4 bars on charging, both ports work, power works fine. And we'll move on to the next ones. Alright, so I finished assembling all the power banks and tested them all. And let's see the results now. Here we have it. I assembled all the power banks that had a good battery. Remember, this one I chipped. When I tried to disassemble, I didn't know that it had 2 screws in it, and I will not use it. Even if it got a good capacity, it got 9479 milliamps, I will put it aside. The next one is this battery, which falls short on only 2166 milliamps, so I will not use this anymore. This got disqualified. And also the third one is this battery, which is 8734 milliamps. This tells me that one of the cells is busted, and I will probably disassemble this in a different video and measure all those cells. So these 3 are dead because they did not match the quality. 2 of them did not match the capacity required to call this a good power bank. And let's move on the other power banks that were assembled fully, and let's see if they are functional. The first criterion is to check if they are fully charged. We should see 4 LEDs for the charge status, and this shows just that. This one has a light as well. It works just fine. And we also have to test both charging ports. Let's do that. Alright, it's charging. 25 minutes until full. Okay. Port number 2 works as well. So one is fully fixed. Let's put it aside. The next one is this 2000. The next one is this 20,100 milliamps, and we saw that the capacity was alright. Let's see if it actually works. We see 4 LEDs at the battery status, and let's check the charging now. Alright, works fine. 24 minutes until full. Port number 1, and let's see port number 2. So this one works fine as well. So great job so far with these that are fixed. Let's move to the next one. Charging status, 4 LEDs. Lights on. Let's see the charging status now. Alright. Port number 1 works. Port number 2 works as well. The only thing I had to do to the USB ports on some of these is to clean the dirt. There was nothing bad on the electrical side, so I just used the tweezer to clean the dirt inside the port. Let's move to the third one. Capacity is full. LED works fine. Let's check the charging ports. fine. This one works fine as well. Not sure if you can see it on the camera, but it says that it's 24 minutes until full. So all of these so far supported fast charging. I saw the smaller ones starting on fast charging, but then they switched to slow charging for some reason. Maybe they didn't have enough current to power this mobile phone. So it shows that it's charging port number 1, port number 2 charging as well. The capacity is shown as full, 4 bars. LED is working, so great job on these. Right, so remaining 3 items. I already looked at these and I know something that you're going to find out soon. So we have 2, 4, 5 that are fixed. We have remaining 3 right here. So 8 with 3 broken, that's 11, that's fine. So right now we're going to find actually how many there were fixed and look through the comments to see if anyone guessed right and who is going to win the $100 that I promised at the beginning of this 2-episode series. Okay, so right here we have this device. This shows 3 bars. So I picked the one that did not want to charge, and I think the charging part is broken on this device, because when I plug in the charging, the LEDs are just blinking. It's the way I saw it on the other devices. When you plug it, it will start blinking just the last bar, but these 2 are fully charged and these are working. So the final answer for this, well, let's test the USB ports as well. Alright, so this one is charging, 25 minutes until full. So now that they are fully charged, I think no, it's switched to 35 minutes until full. I think they don't have enough current to support the fast charging, but it's fine, it works. That's another reason to buy the bigger ones, the bigger packs, because they have multiple cells in parallel and they will support higher current draw. Alright, so this one works as well. Alright, so we have it right here. It's 7 devices out of 11 which were fully fixed. After we tested the capacity and saw they still have a good amount of life in them. They are above 90% lifetime on these batteries and they are now fully functional. Tested all the USB ports so that the capacity on these devices shows properly, and this is it, guys. We have 7 devices, and if you guessed that I'm going to repair 7 of them, you guessed right, and we are now going to look through the comments to see who got this right in the past video. Let's see. Alright, so let's see the video where I announced that. So this one. And let's check the comments. I'm going to order them by time, so it shows them in chronological order. The first one is Dix, I think it's 10. but that's not the answer. All right, we have here the first 7. No, this is this is newer than the Thomas Valatis, but let's get down. And actually Antonio Rivera was the first one that guessed this right on this video. Let's see it. Let's copy this. The lucky 7, it's for Antonio Rivera. But I also posted a short video, and let's see if we have any comments there. Let's check it out. Seven or 8. Well, that's not the right. You wanted to get 50 bucks, put 2 spreads. Doesn't work like that, unfortunately. You had just 1 to guess. E-bike unlock 10 devices. Well, no, that was not the right answer. So it looks like Antonio Rivera got this right, and it was the first comment as well. So that's very nice. You can get in touch going on deepcyclepower.com. Go to contact us page, find the email address there, and get in touch to get the $100. If you have PayPal, it will be an easy way to transfer you the money. So that's it, guys. I hope you enjoyed this video and will learn something about power banks. We can fix them in large proportions. More than 17% of these devices were in working condition, and just 2 of them were out of the capacity. You could still use them on some low power devices maybe, but I will not bother doing that when I have the rest of bigger capacity devices that are in good shape and can use them to charge my phone. I'm going to think about some interesting videos that we can do with these power banks, maybe something that we can do with them, see how much power we can get out of them, how many amps each will deliver, and things like this, and other things that will be interesting to see about these power banks. Thank you very much again, guys, for watching. If you enjoyed this video, don't forget to share it to your favorite groups, like it, and subscribe to the channel, because I will have a lot of new videos coming soon about batteries. Give you a sneak peek. I just finished a few days ago disassembling a big Huawei battery. Looked inside, saw how everything was laid out there. So keep looking for that, because I will be posting that in a few days after I finish editing it. So again, guys, don't forget to subscribe. This means a lot to me to get this channel off the ground and start spreading the word about the batteries, because they are around us. We're using them every day. They are an expensive source, and it's going to rise prices in the future as well. So it's a good thing to know how to fix this, how to diagnose them properly, and how to customize your banks for different projects. I see you on the next video. Thanks for watching.